Hi guys, we're going to go ahead and start our AP review with one variable data. So at the beginning of this year, this is actually the second unit that we did, but it officially is called the first unit in the College Board curriculum. Okay, so while we had collected data first and did experimental design first, and then we addressed this unit, which is how to graph and represent all the data. So let's take a look at all the different ways that we can represent the data. So there were quite a few thinking maps that I had made to go along with this, and one of them is the one that's about the different types of data that we have. Okay, and so first of all, we've got the data that is categorical. Only be put into categories. Okay, so remember we had our pie chart. I think I even sent you a recent pie chart somebody in the news media did wrong. This pie chart, you need to make sure you just have 100%, that it doesn't violate the area condition, doesn't make things look bigger than they actually are, that if it is half of the pie chart, then it is 50% of the data. Mosaic Plot, which I'll remind you how that works here at the end of this presentation. I think it's the last one. And that Mosaic Plot is just a more specific type of bar chart. And so bar chart, remember, have those separate bars. And so here are the different kinds of the bar charts. You could have them stacked, where they are stacked on top of each other, or segmented, where they are, I think those are actually the same thing, stacked and segmented. But then side by side is where those bars would be side by side to each other, males and females that oppose whatever concept, and then males and females who are for the particular concept. Okay, but then we actually have several numerical types of graphing. We use those more frequently than the categorical. Our box plot, our scale, box, fences, whiskers, scale, box, and so on. We'll talk about that. We've recently made dot plots and stem and leaf. We'll review that. And then histograms, which are similar to bar charts in that they are these types of bars, but there are some defining characteristics that make this histogram. The first and foremost being that bar charts are categories, so those bars can be switched around in any order, but histograms are quantities, therefore are in order from least to greatest. Okay? All right, so let's go ahead then and take a look at these. So first of all, we know that we want to address the shape, and it could be symmetric, mound shape, unimodal, you could say that kind of thing, skewed, okay, so it could be uniform. So here's one that is sort of uniform because that is almost straight across the middle, as opposed to unimodal, one mode. You can also have bimodal. Now let's talk about the skew. Remember your foot. If you were to look down at your feet, this would be like your left foot. This one is your skewed left. Tail is to the left, skewed to the left, okay? A skewed to the right would look like your right foot, okay? Here's your big toe, and then here's your pinky toe. So you would have the kind of the curve where you have the tail to the right for skewed right. Okay, so we want to talk about the shape. If we were describing that distribution, we know we talk about that shape, symmetric, unimodal, bimodal, outliers, center, and spread. Okay, and these are some of the things that contribute to its shape. All right, for our dot plot, we know that we have all of these individual dots. And typically, you actually just have these are like there's 10 and then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So one thing about the dot plot is you actually are able to see the individual values. When we've been making our quote-unquote dot plots, we've kind of been putting them into bins. And I think technically that's not really our dot plot. When we put them into bins, that's because these numbers go from like 10 to 15. And so that's really just using dots to put them into our bins, which will be making a histogram. Dot plots technically allow you to determine that individual piece of data. Okay? So I can identify every piece of individual data. Here's your stem and leaf plots, okay? The good thing about stem and leaf plots is that if you turn it sideways, if you look at that on the side, you can see really the shape of this. So this is unimodal. It's a little skewed to the right, but it is probably somewhat symmetric. Just pay attention to which way it is going. If you were looking at quiz 1, make sure you think in terms of this. This is like actually a backwards one, because you have to make sure you think when you're doing the shape from least to greatest. Okay. This is comparing the quizzes back to back. Recall this first number here is a 13 and then another 13. You are reading from the stem out to the leaves. Now, make sure you have a key. I see this one did not have a key associated. Make sure you have a label of what these values are and are about. Okay? All right, moving on. So, next we have that ability to show you the difference between those bar graphs and histograms. Bar graphs, you would not indicate a shape to a bar graph, and that's because I could rewrite those bars in any order and make it any shape I wanted. I do not have to put these, A and then B and C and D. I mean, I could switch all of these around in any order I want. Okay, but yet histograms are going from least to greatest, therefore you can discuss the characteristics of its shape. All right, so now our measures of center. We like to use the mean when we're dealing with all of our problems about t-tests and z-tests and all that kind of stuff. But that's because we've established that they're approximately normal, okay, or they follow the normal model or the t-distributions, okay? Then we can use that mean or that average. Remember when you might want to use the median to demonstrate is a better measure of the center. And that's a better measure of the center if you have a skew to the shape or outliers. Because you can see down here that if we have, symmetry, then our mean, median, and mode are the same. But look here. If we have something that is skewed left or skewed right, then our median and our mean are not going to be the same. The mean is pulled in the direction of the skew. So if you are skewed to the right, then you've got a higher mean than median. Remember that we had that little thing that we used where we wrote them in order: mean, median, and then mode. And after we did that, then if it was skewed right, we would draw our inequalities pointing to the right, and we could see then that the mean is greater than the median, and that's greater than the mode. Okay? But if it was skewed left, and we drew our inequalities to the left, then we can see that that's because our mean is less than the median, which is less than the mode. Okay, so you would want to draw your inequality like the shape, and then that'll tell you the relationship between the mean, the median, and the mode. All right. Now, let's talk about the spread that we will be using to go along with those. I think by now you know that for the most part, we put mean and standard deviations together. So the issue with the mean and standard deviation, okay, is that they give this better measure and more complete measure, holistic measure of spread. Of course, that standard deviation being that average distance from the mean, from the mean, from the mean, average distance from the mean, standard deviation. But the problem is both mean and median are affected quite a bit by any outliers or skew. Okay, so we would definitely not want to use the mean for center and standard deviation for spread in the event of skew or outliers. Okay, however, our median, and our IQR are good measures. The median, if you have outliers or skew, that doesn't matter because you're cutting off those numbers and finding the center location regardless of the far outside reaching items. So we like that. The IQR, remember the IQR is Q3 minus Q1. And if we take a look over here, remember that, your median is the center of the data. But if you take that top set, if you take the top half of your data, then Q3 is the middle of that. So Q3 is the middle of the top half. Q1 is the middle of the bottom half. Okay? And so this IQR is that middle 50%. The middle 50% is that IQR in your box plot. Now, so here's some things that I've kind of talked about a little bit, and here's another thinking map we had. If you have skew, then you must choose to use median and IQR. Ooh, symmetry, standard deviation, and mean. Okay, so remember our little song to guide us through which measure of center or spread is a better one to use and why. Median and IQR are resistant to the skew, resistant to outliers, and yet symmetry, the mean and standard deviation are not resistant. Therefore, we can only use those in the event of symmetry. Here is the fences for our median and IQR ones. Remember Q3 plus 1.5 IQRs. The lower fence is Q1 minus 1.5 IQRs, but you remember for standard deviations, it's the 2 plus or minus 2 standard deviations. All right. Here is another thinking map to remind you about, and it might, what we know. If we are given, say, we are told that, hey, the mean is greater than the median. If the mean is greater than the median, then I know, I have this going on. So I know my shape is skewed to the right. Okay? Whereas if my data has the mean is less than the median, then I know my data has this shape here, a less than shape. So it is then skewed to the left, okay, as opposed to being skewed to the right. If they are somewhat symmetric, if they are pretty close to each other, then they're somewhat symmetric, okay? So that's another way to tell that. And then we know the difference between this larger standard deviation is because the data is more spread out, smaller standard deviation, it's more closely clustered around the center. All right, and then here is your help for making those box plots, okay? So we first, remember our song goes, scale, box, fences, whiskers, scale, box, fences, whiskers, scale, box, fences, whiskers, put those outliers on. Okay, so you did need to get that 5-number summary where you either let your calculator do it or you're putting the numbers in order and finding the median. Okay, there's your middle. And then remember this Q1 is the middle of the bottom half. Q3 is the middle of the top half, and so on and so forth. You're going to look at your data and see, what's the min and the max. So how about how far do I need to spread my data out, and then you make your scale. You start then and you put your box on there, your Q1 to your Q3 with the median in the middle. Draw your dotted lines for the fences. Compute them and draw your dotted line for the fences so that you can see any data below the lower fence or any data above the upper fence is an outlier. Okay, and so that's what I have here. Data above the upper fence or below the lower fence is an outlier. And you would put a dot for each one of those outliers. Now, finally, remember that your whiskers do not touch that fence unless it's on the, so if this is your box plot, here's a fence, and you have an outlier out here, your whisker goes to the next piece of data inside the fence. So if that next piece of data inside the fence is right there, your whisker goes to that. Don't touch that electric fence unless you happen to have a safety point on that fence. But otherwise, your whisker always just goes to the next piece of data inside the fence. All right, and don't forget to label all of those points. All right, moving on. So here is our normal model stuff, which we've been doing a lot of. So I don't have to go over this very much because we've practiced it a lot, but do remember that rule where we have the 68, 95, 99.7. So that's the ones within one standard deviation was 68%. Within 2 standard deviations is 95%. So you have 5% of your data that are outliers. Within 3 standard deviations is that 99.7. All right, and then we've got our standard normal model with our x minus the mean over the standard deviation, x minus the mean over the standard deviation. All right, now let's talk about one of the final graphs that we learned about before we start talking about going in between. So like going from a histogram to a box plot to a histogram. Remember our cards that we use to match up all those different things? So our final graph that we learned about was this cumulative frequency curve. So it accumulated as you would go along in the chart. So we can see here that, for example, see how these bars are kind of about the same height? They're uniform. So what that means is we were actually adding the same amount of data, pretty much, with each bar. So when you have this uniform section, you're accumulating data at about the same rate. That's why this looks almost linear right here. Okay, but now here I have these smaller bars. So because of these smaller bars, do you see how I have a much slower rate of growth because I'm accumulating less data? Okay. All right, so then here, I've got this rapid growth right here. So I have a steeper slope on my cumulative curve, and then it kind of starts to accumulate at a slower rate. It's not quite where we're lowering the rate of increase there. You can see that very clearly here. Quick rate of increase here, but then we add less and less, so we are flattening that curve. We are lowering that rate of increase. Again here, these steep increase, flattening it out. So another thing to keep in mind is that when you have a cumulative frequency curve, one of the things that is ideal to use it for is the identification of your quartiles, because with this accumulation, you can find out where the 25th percentile of all the data is, and the 50th percentile, and the 75th percentile. So you can then identify where the median, Q1 and Q3 are pretty easily. So then you could kind of think about superimposing this box plot on top of your cumulative curve. You then could count, how big is this IQR. You could measure the size of the IQR and then add 1.5 IQRs. You could even then kind of approximate a fence and see if you had any outliers. You could approximate where your fence would be 1.5 IQRs out and see if you have outliers. So there's quite a bit of things you can determine from that cumulative frequency graph. All right. Now, this here is kind of that connection between histograms and box plots. And so I don't have a very good picture of this. If I was thinking, I would have pulled up those histogram cards. And in fact, I think I'll do a separate little video, or I'll pull that back in here and do our little matching game. Do you remember when we had the different matching between the histograms, the box plot, and the data? So I'm going to do a separate video on remembering how to match those items together. I think that will help you with that, and I'll pull this out then. All right, let's take a look at our Mosaic plots, new to the AP stuff this year. So here we go. On the left, I have just a regular old bar graph, okay? On the right, however, it is a Mosaic plot. So let's take a look at what's the difference between those two. Okay, well, I can clearly see on the left the widths of all the bars, and these are the math AP exams, okay? The width of all the bars are similar widths, but over here on the Mosaic plot, some of them are wider than the others, okay? And they are touching. So there's a reason that we have those different widths, and let's look at that. So the Mosaic plot on the right has varying widths, which indicates the different proportion of the nation that took those AP exams. So this tells me then which was the most highly given exam. What test had the highest proportion of the nation's math AP tests given? And that would be the Calc AB. So Calc AB had the most tests. Highest proportion of tests. I can see statistics had the second most proportion of tests, and so on. Whereas you can't see that on the left. All right? Now, so, if we take a look at the x-axis, so the x-axis is, again, telling us that proportion of all the AP mathematics tests taken, and then what proportion of those were for each specific type. So we can see the largest proportion of all mathematics tests was the Calc AB. But what about the y-axis? That y-axis is the proportion of each specific test, and the proportion of those tests that had 1s, 2s, 3s, 4s, and 5s. Okay? So, for example, here, it's interesting. I can see that those Calc AB tests were almost evenly distributed between 1s, 2s, 3s, 4s, and 5s. Okay, here's our 1s, 2s, 3s, 4s, and 5s. However, Calc BC was much different. Calc BC had a much lower proportion of 1s than 5s. It was the Calc BC was the test that had the highest proportion of 5s. Okay, so that y-axis is telling us specifically amongst each test what distribution is happening. Okay, so that's the benefit to those. Here was another thinking map just to remind you of your SOCs describing the distribution, what kind of words you are using for shape, what kind of situations you have for outliers, either that IQR rule or that standard deviation rule. The center, if you have skew, then you want to use that median, and for spread, IQR. But for symmetry, you can use that mean and standard deviation. Okay, and when you are doing both, all of these things, you definitely want to be specific. If you are describing those distributions, give specific numerical values, and if you had two distributions which you are comparing, and I could see that happening on the test, that's a good way to get a lot of information from you in a short amount of time. Then make sure you're using comparative language, like this distribution is higher than a center, has a higher mean than this, and you would compare those numbers. All right. Now, then we have all of the songs, and so I'll list those songs, the videos, direct link to those songs in the Canvas to help you with that, but they, of course, are on the YouTube playlists. Um, do keep in mind, okay, so we know this independent one. Here's our interquartile range, the middle 50%, and then that tells us the lower Q1 minus 1.5 IQRs, and so on. Sentence paradox is not tested, so that one is not a technical one. Here is our box plot song, our Sing to You Guys. Then there's your outliers, how you have those outliers, okay? There's your describe the distribution. Now, and then I like this one here, when to use what measure. I liked this faithfully one because of this little section right here. The measure that, all I know is that I need resistance. The measure of center that is resistant to the skew. The measure of spread that is resistant to. So those are the measures that I should choose to use. If you have that skew and outliers, then you're going to want to use IQR and median because they're resistant. Okay, and then of course I sang your little the if you have skew, then you must choose to use median and IQR song. Now let's look at this last idea, and this again is that transformation of all the data. And we see this several times throughout the year. So, we're using it a lot of different places. So don't forget that when we are transforming that data, that when you are adding, and I didn't grab my ball, remember my ball that the spirosphere or whatever. When you have your piece of data and you add or subtract from that piece of data, then that just adds to the measure of center and spread. That is increased or decreased, but the measure of spread is not changed because adding and subtracting does not change the spread. Okay? However, that multiplication is that stretching, that multiplying or dividing, which, dilating or just, taking it back down, shrinking it, then that will affect center and spread both. Okay? All right. Now, we did talk about this. We'll revisit this association between the two variables at a different time, I think. The time that we see this occurring in this unit is if we were comparing two stacked bar graphs together, and we saw something like this, where the stacks, this would be the people who watched the game, this is the males and the females, and these are the people who watched the Super Bowl game for the game itself. Here's the people who watched for the commercials, and here's the people who did not watch the game at all. So this is the type of situation in this unit where we address if the variables male and female and what they are doing with the Super Bowl are related. Okay? And in this case, there was not a relationship. In this case, the fact that you are a male or female is not changing the rate at which you watch the Super Bowl for the game, the commercials, or you do not watch. Because you can see these all have the same size segments. Okay? So that's where this would come into play. They are independent because the variables are not related. The fact that you are a male or female does not change the rate at which you do your Super Bowl activity. Okay? And over here, it does change the rate. All right, so that's the conclusion of all of the one variable data. So now you're going to go into your Canvas activity and you're going to do 2 different multiple choice progress checks and then one free response that has just 2 free response questions for you to work through and check.